Hello dear students. The today's session we will discuss the preparation of the glycols. The last session in the classroom we completed the preparation of the alcohols and monohydric alcohols completed and their physical properties, chemical properties completed. Now we are going to be discuss about the dihydric alcohol, preparation of the dihydric alcohols. Preparation of the dihydric alcohols will be discussed. So this dihydric alcohols, generally the chemical formula of this CH2OH and CH2OH. So this is a dihydric alcohol generally, and this is we can call as a ethylene glycol also. We can call ethylene glycol. So otherwise we can call this is an IUPAC name here, ethane 1,2 diol. Ethane 1,2 diol, because 2 carbons is present and 2 carbon 2 alkyl groups is present. The alkyl group suffix is, functional group of alkyl suffix is ol. Functional group of alkyl suffix is ol. So the ol present on 2 position, one is 1 and one is 2. So totally 2 alkyl groups are present. We can call that is an di, and alkyl groups is present ol, and that is present at 1,2 position, and this is an meth and eth, carbon to carbon single bond is there, we can call ethane. So finally we can call it as an ethane 1,2 diol. So now we are discussing the preparation of this dihydric alcohols, otherwise ethane 1,2 diol. First preparation method from ethylene. First preparation method from ethylene. So how to prepare the ethylene glycol from ethylene will be discussed. So here first I am taking the ethene I am taking, that is a CH2 double bond CH2. We can call this is an ethylene. So this ethylene we are reacting with the cold diluted alkaline potassium permanganate. We can call it is an Bayer's reagent. And when you react with this Bayer's reagent, this ethylene is converting into ethylene glycol. So whatever the one of the pi bond is there, this pi bond will be break here, and when you use the Bayer's reagent, so the unsaturated or alkene, the pi bond can be break, and OH and OH can be addition takes place here. So resulting of that ethylene glycol is possible. And when you take the more amount of ethylene, for example I am taking 3 moles of ethylene I am taking, and this 3 moles of ethylene I am reacting with 2 moles of potassium permanganate Bayer's reagent, and with 4 moles of water because diluted. And when you react with that, the product formation is here 3 moles of ethylene glycol CH2OH and CH2OH, because I am taking 3 moles of alkene. So due to the 3 moles of alkene here, 3 moles of ethylene glycol formation takes place. At the same time, the formation of the 2 moles of potassium manganese dioxide formation takes place. At the same time, 2 moles of potassium hydroxide also formation takes place. So when you take that 3 moles of ethylene with the 2 moles of potassium permanganate and 4 moles of water, because of diluted we are taking. So the formation of the alcohol is 3 moles of ethylene glycol and 2 moles of manganese dioxide and 2 moles of potassium hydroxide formation takes place. This is what here we can prepare the glycols by this method. And if you want to prepare higher alkenes, if you take as a higher alkenes I am taking, for example, if I take as a higher alkenes, I am taking what here? Higher alkenes. So higher alkenes nothing but you are taking here, and CH3 and CH double bond CH2. So this higher alkenes, when you react with the Bayer's reagent, it will be formed as a syn addition. The OH groups will be add same side of the double bonded carbon. So here OH and here also OH. So same side addition will be takes place. You can call this is an syn addition. So the product name is propane 1,2 diol. You can call it a propane 1,2 diol. So not only this one, when you take a cyclic compound, for example cyclopentene I am taking, right? So this is that a cyclopentene, and when you do this is an oxidation process, same, because we are doing all our oxidation process only. When you do the oxidation of this and we can get that here pi bond is present, the pi bond can be break, and we can add the two OHs, that is in way syn addition. So here also OH and here also OH, here hydrogen and here also what will be hydrogen. So syn addition is takes place. So always when you take that potassium permanganate, Beer's reagent, so the unsaturated hydrocarbon means alkenes will be give that syn addition of that diols will be give. So this is what from ethylene, preparation from ethylene. So once again if you check that, preparation of the diols from ethylene, I am taking ethylene and reacting with cold diluted potassium permanganate, we can call it the Beer's reagent. And when you react with this base reagent, carbon to carbon, what the pi bond is there, that will be break, and we can add the two OH groups here. And same way here also we taken 3 moles of alkene. How many moles of alkenes we are taking? That moles of glycols can be possible. And when you take the higher alkenes, it will be the formation of the cis addition, otherwise syn addition will be takes place. Here also syn addition, the two OH groups are present same side, and here also syn addition, the two OH groups are present at same side. And we can prepare not only this way, another way also we can use, but generally here when you use the potassium permanganate, Beer's reagent, when you can use, it will be formed as a syn addition. Right? For example, I am taking an alkene, I am taking, this is carbon to carbon double bond is present, right? So this is a carbon to carbon double bond, and when I am taking Beer's reagent, right, cold alkaline diluted potassium permanganate, and one more is here I am taking peroxyacetic acid or C double bond OOH, we can call peroxy, right, acetic acid, otherwise peroxy, what simply you can take, if you take as a CH3, we can call peroxyacetic acid. So when you take this peroxyacetic acid and Beer's reagent will give the syn addition of hydroxyl groups, and peroxyacetic acid will give that anti-addition of hydroxyl groups. So we can write here carbon to carbon double bond, what is there, it will be converted to single bond, and here OH group will become, and here also OH group will become. We can say this is an syn addition because OH groups are, two OH groups are same side only present. But when you come to the peroxyacetic acid, anti-addition will be takes place, and here, and this is the one of the OH group, and here one of the OH group. So OH groups are present opposite direction. We can say this is an like an anti-addition we can take this is. So what will be given? A syn addition of hydroxyl groups, and here what will be an anti-addition of hydroxyl groups will be. So when you take the alkene that I am reacting with the Beer's reagent and peroxyacetic acid, Beer's reagent it will be give the syn kind of addition of OH groups. And when you take the peroxyacetic acid, anti kind of addition will be given by the hydroxyl groups. So this is what is syn addition and anti-addition to different reagents. Beer's reagent will be given the syn addition, and peroxyacetic acid will be given the anti-addition. Okay. So, and this is one of the preparation method of the glycols with the help of potassium permanganate or Beer's reagent. And the second one is we can prepare that by the addition of oxygen, by the reacting with oxygen otherwise. So I am taking here, for example here I am taking, so an alkene I am taking, that is a CH2 and double bond CH2. This I am reacting with half mole of oxygen in the presence of catalyst silver, and it will be formation of the oxirane, otherwise glycol, epoxide will be formation takes because half mole of oxygen at 1 oxygen. And after that I am doing that hydrolysis process, right, in the presence of H2O, I am adding the water to this one, in the presence of acid, H plus and OH minus will come, and this bonded electron will be taken by this oxygen, H plus will be come to here, and this carbon will get the positive charge, OH minus will be come to here. So the resulting of that, the formation of the glycolysis takes place, CH2OH and CH2OH. So this way also we can prepare that. So this is what is second process. And when you come to the third process here, to the same alkene I am adding that hypochlorous acid, CH2 double bond CH2, I am adding hypochlorous acid, HOCl. When I am adding hypochlorous acid here, chlorine is behaving as electrophile, OH is behaving as a nucleophile, and the product formation is one of the carbon side OH will become, other carbon side Cl will come. Right. So but it is not a glycol nothing but 2 OH group must be present. Here one OH group is present, one Cl group is present. We can call this is an ethylene chlorohydrin. We can call this is what here? Ethylene chlorohydrin. Ethylene chlorohydrin we can call. And this ethylene chlorohydrin we can react with sodium bicarbonate. Right, we can react with what here? Sodium bicarbonate, boiling sodium bicarbonate. And when react with that, this chlorine group is replaced by the OH group. So now all glycol is possible, CH2OH, at the same time CH2OH. And whatever the sodium is present here, and this sodium and this chlorine is eliminating in the form of a sodium chloride, right, one of the product, and here hydrogen is present and OH will be come to here and remaining is CO2, right. So the CO2 will be formation takes place here plus CO2. So this is the preparations of the ethylene glycol. So from where first one is from the ethylene, from the what Bayer's reagent, and the second one is with the help of by oxygen and silver behaving as a catalyst. Third one is hypochlorous acid, and the fourth one is third one is hypochlorous acid. So this is the way we can prepare the what here glycols with the help of different reagents, and this you can write in your classwork notes. Right, so completely you have to note in your classwork note this is. Okay, better take the screenshot and you can write your notes. Yes, and the next process is by reduction of glycols. So now oxidation is completed, right? So next one is reduction process here. So after completion of the oxidation process, next we are discussing about that reduction process. In the reduction process, you can prepare the glycols. So by reduction of second process here, by the reduction of glycols, by the reduction of glyoxal, right? So by the reduction of glyoxal, so glyoxal nothing but here two aldehyde group is present simply. So CHO and CHO, we can call this is an glyoxal. This is we can call what here glyoxal. So this glyoxal, from this glyoxal we can prepare the what here glycols we have to prepare. So I am taking that here glyoxal and I am doing the reduction process. Reduction process nothing but what we know. Reduction nothing but addition of hydrogens, otherwise removal of oxygens or electronegative species. Removal of oxygens or electronegative species. This is we can call as a reduction process. So let us see here what you have to do here. So I am taking that glyoxal I am taking, that is a CHO and CHO, that I am reacting with the lithium aluminum hydride as strong reducing agent, and it will be released as the hydrogens. So now you write here one of the hydrogen which is releasing from the lithium aluminum hydride, and two hydrogens we add here, two hydrogens we add here. So one of the hydrogen with oxygen, right, and one of the hydrogen with carbon, one of the hydrogen with oxygen, one of the hydrogen with carbon. Then it will become CH2OH, and one more is what here CH2OH. It's a direct process to remember how the product formation takes place. So totally two hydrogens are adding. It will be CH2OH. It is also will be CH2OH. We can prepare the glycols we have prepared. So next one, this is what by addition of the hydrogens here, one of the reduction process. And the second one is removal of the oxygen or removal of the electronegative species. And the next one here, we can prepare the glycols from 1,2 dibromoethane. From 1,2 dibromoethane. From 1,2 dibromoethane we are preparing that. So how to prepare from 1,2 dibromoethane? So this is now CH2, CH2 and Br. This is 1,2 dibromoethane. This is what here 1,2 dibromoethane, right? This 1,2 dibromoethane is reacting with sodium carbonate and in the presence of water. So just now we discussed that reduction nothing but addition of hydrogens or removal of electronegative species also. Bromine is electronegative species. We are removing the bromine from here. So removal of electronegative species also what we can call reduction. We are doing the reduction process here. So in the bromine place we are adding the hydroxides. So now here, so now we can write here CH2OH and one more is what here CH2OH. Glycolysis formation takes place. At the same time, the two OH groups are coming from here, H2O, and from here one oxygen. So H2O nothing but you can write HOH, from here one oxygen. So totally OH and OH. From the CO2 one oxygen is eliminated, will be converting into CO2. And two sodiums react with two bromine, eliminating in the form of a sodium bromide. And one of the oxygen from CO2 will become to here, just imagine such way, and will be formed as a 2 moles of OH. The two OHs are adding here, and the next one is carbon dioxide formation. So this is what here preparation of the glycol is completed from 1,2 dibromoethane, right? That is the elimination of the bromine. Right. So once you see here, so we discuss the two process. One is by oxidation process, one more is by reduction process. If we come to the oxidation process, we discussed already. And next one is reduction process by the reduction of glycols, Glaxol. So Glaxol nothing but CHO and CHO group we can call as a Glaxol. And by reduction nothing but addition of hydrogens or removal of electronegative species. First one you are adding the hydrogen. For that we need some reducing agents. The best reducing agent is lithium aluminum hydride. We already discussed that. So now resulting of that glycol is formation takes place. At the same time removal of electronegative species also, bromine. And when you remove the electronegative species, you are adding the OHS and resulting the formation of what here? Glycol. So this is about what? Preparation methods of the glycols. And the next one is physical properties and chemical properties. When you come to the physical properties, it will be colorless. So I am discussing about that physical properties of that. Physical properties. So physical properties of the glycol is, first one is, it is a colorless. It is a colorless compound and it will be syrupy liquid, like a syrup kind of structure is it. It is a syrupy liquid we can call it. Syrupy liquid. And it will be sweet in taste. And it is having some kind of sweet in taste. Right, sweet in taste. So next one, it will be miscible with water also. Miscible with water. At the same time, alcohol. But insoluble in ether. So this is simply physical properties of the what glycols. And when you come to the chemical properties are important here. Chemical properties. So when you come to the chemical properties here, so if you take that glycols, two OH groups are present, CH2OH and CH2OH. This is the first group and this is the second group. And chemical properties, when you take the metals, otherwise when you take the acids or any other substances, the two OH groups does not react simultaneously. First one of the OH group will be react, after that the second OH group will be react. And let us see, for example, I am taking a different kind of groups I am taking here. So if you see that here, I am writing here better. So first I am taking CH2OH, here I am taking that and CH2OH glycol I am taking, and it is also what here, CH2OH, it is a glycol. We are reacting this with a different kind of species, and what will be the product, let us see here. Right. So this is that, and first I am reacting with the sodium metal. Right. So sodium metal, when you react with alcohols, we discussed alcohols having some kind of acidic nature, and this sodium active metal will replace the hydrogen place from you. And when you take the 1 mole of sodium, initially first OH group hydrogen is replaced by the sodium and eliminating as half mole of hydrogen gas. And in the second step, again when you take the 1 mole of sodium, it will be formed as a 2 sodiums will be formed by replacing of 2 hydrogens in each step. So this is the formation of that product. And the same way in the second step, and the second we are taking PCl5, phosphorus pentachloride. So I am taking PCl5, I am taking, next one PBr3 I am taking, next one is phosphorus triiode I am taking, next one is thionyl chloride SOCl2 I am taking. So when you take the PCl5, PBr3, it will be take the 2 step. For each step, one of the OH group is replaced by the chlorine. But when you take the phosphorus triiode, 2 moles I am taking, directly in a single step, 2 hydroxy groups will be replaced. Same way when you take thionyl chloride also, a single step only, the 2 OH groups are replaced by chlorine. So I am taking PCl5. First step what happened, one of the hydroxy group replaced by chlorine, and the remaining is OH here only. And again I am reacting with the PCl5. This time the remaining OH group also replaced by chlorine. This is the product formation. Same way reacting with the bromine. First one of the hydroxy group replaced by bromine, and the second 1 more mole of PBr3 when you take, it is also replaced by the bromine total. Next one, Pi3, phosphorus triiode. Just now we discussed that a complete replacement is takes place here, CH2I and CH2I, but it is an unstable. It is what here? Unstable here. Right. So due to the unstable, again this iodine will be give the bond and eliminate in the form of a I2, and the resulting the product is alkene is possible, CH2 and CH2. And the next one is SOCl2, thionyl chloride. Here also direct replacement is takes place, but it will be formed as a stable product, CH2Cl and CH2Cl is possible. So this is what here, sodium, PCl5, PBr3, Pi3 and SOCl2. Next one, reaction with hydrochloric acid. When react with hydrochloric acid, here also 2 steps will be takes place. First step is OH replaced by the chlorine, And the second step, when you take 1 more mole of HCl, here also the chlorine is, the hydroxy group is replaced by the chlorine. And the next one is HNO3, nitric acid. When you take the nitric acid in the presence of sulfuric acid, nitration, generally we can prepare the nitrobenzene, that way you prepare that. Same here also, electrophile is NO2 plus, and that electrophile will be added here. So in the place of OH group, that will be CH2O, one of the hydrogen is eliminated from here. So ONO2, and the next one is CH2ONO2, and this is the product of formation here. And when you heat that, when you heat the glycol, so from here hydrogen, from here OH, H2OH will eliminate and will be formed as a cyclic product, CH2 and CH2O. We can call epoxide, otherwise oxygen also we can call. So generally this is reactions, and some more reactions there here, and I am writing here that CH2OH and CH2OH, CH2OH and CH2H, single bond only, not double bond. The CH2OH and CH2H, you don't have place that, so I am writing here. And when react with the diluted nitric acid here only nitric acid and sulfuric acid combination, we are taking only diluted nitric acid, the resulting product is COOH and COOH is possible. And the same when you reacting this with the potassium permanganate in the presence of acidic medium, KMnO4 acidic medium, we discussed that this is a strong oxidizing agent, potassium permanganate and acidic medium. It will be convert the primary alcohols to carboxylic acid directly. So it will be now the product of formation is 2 moles of formic acid. 2 moles of formic acid takes place. Here one of the formic acid and here also one of the formic acid. Next one, periodic acid. This is very important. The coming reactions also we have more questions on with periodic acid. When you react with periodic acid, it will be formation of 2 moles of formaldehyde takes place. 2 moles of formaldehyde. For example, if you see that CH2OH and CH2OH, when you react with periodic acid, here you have to break the bond between hydrogen, oxygen to hydrogen here. So this is one of the oxygen to hydrogen bond formation, bond is breaking, and here also oxygen to hydrogen, here also carbon to carbon bond breaking is takes place. See what will be formed when you react with periodic acid. Just remember in this way: oxygen to hydrogen bond breaking, oxygen to hydrogen bond breaking, carbon to carbon also bond breaking. So totally here you see H, 2 hydrogens, 1 carbon, 1 oxygen. So HCHO, HCHO, and here also 2 hydrogens, 1 carbon, 1 oxygen. We can write here also HCHO. So totally 2 moles of formaldehyde formation takes place, and H2 is eliminated here. So when you take with the periodic acid, you have to break always to get as a simple way. Oxygen to hydrogen bond breaking takes place, and carbon to carbon also bond breaking takes place, resulting of that formaldehyde formation takes place. So this is the complete chemical reactions of the what here glycols. So glycols, when you react with a different kind of elements, a different kind of species, right? So once you check here, reacting with sodium and reacting with phosphorus pentachloride, reacting with phosphorus tribromide and phosphorus triiodide and thionyl chloride. Next one is HCl, and next one is HNO3, and when you heating that, so different kind of product formation is takes place. So this is about what here chemical reactions of the what glycols here. So physical properties is completed. Next one, chemical properties is also completed, and preparation methods also completed. Right? So once you check from here, different kind of reactions. So you everything you should note in your classwork notebooks. And for the continuation process, last class what we discussed for that continuation process is glycols, ethylene glycol. So this is today's session, and in the next session we will discuss about the preparation of the trihydric alcohols. Dihydric alcohols, nothing but we discuss that 2 OH groups are present, and the 2 neighboring carbon atoms, or we can say vicinal position. Vicinal position 2 what here OH groups are present. We call this is an dihydric alcohols. And in the next session, the classroom will be discuss about trihydric alcohols. The 3 OH groups present on the 3 carbon atoms. So what is the preparation method of that, and what will be the chemical properties, and what will be the physical properties of that will be discussed in the next session. So this is the today's session, dihydric alcohols, and this entire notes you have to write in the classwork notes, and I'll send the PDF file also, and better to you copy from that. Thank you.